Hello everyone, I'm here to introduce how I figure out the second part of homework 11. So the first part A of the question 2, fv is equals to e to negative absolute value of v. First, it may represent an autocorrection function because e to negative absolute value absolute v is even, and it is obviously less than the value when v is equal to 0, and itself from the Fourier transform is equals to 2 alpha divided by alpha to 2 times 2 plus omega to 2, which is non-negative. And second, it may represent a power spectrum. That's also because the function itself is larger than 1. So as for the second part, the sub-question B, fv is equals to sine v to 2 divided by v to 2. First, it may represent an autocorrection function because sine tau to 2 divided by tau to 2 is even. It's obviously we can just observe it from the function itself, and we can calculate its limitation to find that when tau is passing to 0, the function itself, the value is less than 1, and the figure of it is like this, and which is non-negative. It may represent a power spectrum also because sine omega to 2 divided by omega to 2 is larger than 0. And for the second part, for the third part of the question, that is fv is to value when the absolute value v is less than alpha, that is v is from negative alpha to alpha, the fv itself is equals to 1. Otherwise, that is when the absolute value of v is more than alpha, that is v is more than alpha and v is less than negative alpha, fv is equals to 0. And first, I think it cannot represent an autocorrection function because we can find it from its Fourier transform, because its Fourier transform is that 2 sine alpha omega divided by omega, and we can find that omega sine alpha omega is non-negative. So from my perspective, it cannot represent an autocorrection function. And for the second part, we can find that it may represent a power spectrum, and the same reason as above, that is because the the value of f omega is larger or equals to 0, and so we can get the 3 conclusion of the homework 11 question 2. Thank you.